In the alternate version of Quick Study 10-5, we're presented with a bond scenario and asked to prove out the market price. It indicates Garcia Company issues 14% 15-year bonds with a par value of $430,000 in semi-annual interest payments, meaning interest is paid every 6 months. On the issue date, the annual market rate for these bonds is 12%, which does imply a selling price of 113 3/4. And it makes sense here. This bond is selling for a premium because of the fact that we're selling above 100%, and that makes sense. The market rate or similar bonds are offering 12%. On the other hand, Garcia is offering 14%, being that they're offering a 2% advantage on their interest payments. Individuals are willing to pay a little bit more upfront in order to secure those bonds. Let's confirm the selling price to be approximately correct. The tables that we're going to use will have a little bit of a rounding error, but we can get there within 0.1%. Now, before we prove out and look at our streams of cash and prove out it comes close to the selling price, let's figure out the exact selling price. So all we have to do is take our par value of 430,000, multiply it times our indicated percentage of 113.75 to get an actual issue price. When these bonds are issued, Garcia would receive $489,125. But keep in mind, that's what they receive up front. There's two streams of cash that they have to pay over the life of the bond. There's the principal or maturity or par value that has to be paid back at the end of the life in 15 years, and that's $430,000. And also there's the interest payments that are going to be paid semi-annually over the 15 years. So let's figure out what those interest payments are. We simply just take par value and we multiply it times the interest rate. However, 14% is the contract rate, but it's an annual rate. But we're paying interest every 6 months. So what we need to do is divide our 14% by the number of interest payments per year, which is 2. 14% divided by 2 equals a semi-annual stated rate of 7%. That's the rate we want to use to figure out every 6 months what the actual interest payment is. 430,000 times 7% gets our semi-annual cash interest payment every 6 months of $30,100. So to prove out our issue price, we're going to take those two streams of cash, our $30,100 paid every 6 months over 15 years, and our $430,000 amount paid out at the end in one lump sum at the end of 15 years. Well, before we jump into our present value tables, let's make sure we understand what the correct length of time or number of periods that we need to use, and also what interest rate that we want to utilize. So, period of time, or what N is here, you might have thought, why did you list 30? This is a 15-year bond. It doesn't seem to make sense. Why don't you list 15 years here? The important thing is that this is being paid in semi-annual or every 6 months. So we take the actual length of time in years and multiply it times the number of periods per year. If we're paying every 6 months, that's 2 periods per year. So 15 times 2 equals 30 semi-annual cash payments. That's 30 total interest payments. We also need to look at our interest rate. And you might have initially thought, well, use 7% up here, and you took the annual contract rate and divided it by 2. So it kind of seems like I'd flow 7% down here, but I'm not exactly sure why you're using 6%. When we look at taking those two streams of cash, the par value paid out at the maturity, and also those semi-annual cash payments, the interest rate we use in order to bring these back to in today's dollar terms and present value terms is the market rate, not the contract rate. So we want to use the market rate. Again, you might be confused saying, well, that says it's 12% and you've got 6%. Similar to what we did up here, being interest is paid every 6 months, we're going to take that 12%, divide it by the number of interest payments per year, which is 2, in order to get a 6% semi-annual market rate. So when we're discounting things, we want to use the market rate, what similar bonds are offering. So we've got several different tables to choose from: present value of $1, future value of $1, present value of ordinary annuity, and future value of ordinary annuity. I'll tell you, we can already strike out the future value tables because we want to put those two streams of cash in today's dollar terms, not in tomorrow or 30 years from now dollar terms. So we can strike those out. So the only two tables that we're going to use is present value of $1, which is also called the lump sum table, and present value of ordinary annuity. Let's start figuring these tables. We're going to start building our cash flow. I'm going to start with the par or maturity value of $430,000. And let's figure out, we're between two tables: present value of $1, present value of ordinary annuity. I'm first looking at the $430,000 that's paid back in one lump sum at the end of 15 years. So that's going to be our lump sum table, or present value of $1. Let's go ahead and navigate to that table real quick. Remember, we said we're going to utilize 30 periods, so we're going to use the row of 30. We also said we're using the market rate percentage, semi-annual percentage of 6%. So the intersection of 6% and 30 periods is going to be a present value factor of 0.1741. So I'll come back here and indicate that our table value is 0.1741. I'm going to multiply that times the lump sum payment at the end of life of $430,000. In today's dollar terms, that payment of $430,000 at the end of 15 years with a market rate annual rate of 12% is the same as having $74,863 today. Now we've got the second important cash flow, and that's going to be the interest. Keep in mind that interest is paid in equal amount over each of the next 6 months for 15 years. So that's going to be our annuity table. So let's go ahead and navigate to our annuity table, also using the row correspond to 30 years. Figure out where that intersects with 6%, and that's 13.7648 is the factor. So let's go back, 13.7648. This time times not our par value, but our annual interest amount is going to be $30,100. 30,100 times 13.7648 in today's dollar terms is $414,320. Let's add up those two streams of cash in today's dollar terms: the par value paid out in 15 years and the interest paid out every 6 months. In today's dollar terms is a total of $489,183. Now, what you realize, the actual issue price $489,125. We came up with $489,183. That's pretty close. Keep in mind that we're using tables and we're rounding to 4 decimal points. If we kept going out farther, we could pretty much get on the penny, but we wanted to come to a reasonable amount. Just to prove out the difference due to rounding, if I take our calculated $489,183 and subtract from it our actual price of $489,125 and divide that by the actual issue price of $489,125, I get a rounding error of 0.01%. That's not 1%, that's 0.01%. So we're well within our difference here. We've